Okay, in this video we're going to go through differentiation, in particular differentiation in C3. Okay, so C3 differentiation. Okay, in particular I want to go through the derivatives of certain functions. So you probably must have learned by now all 6 trigonometric functions. So sine x, so y equals sine x, y equals cos x, y equals tan x, y equals sec x, y equals cosec x, okay, and y equals cot x. Okay, so if you differentiate sine x, so dy dx equals to cos x, and you can actually prove this result quite easily using the first principles of differentiation which you learned in C1, but I don't think you're required to prove this. Okay, the derivative of cos x is minus sine x. The derivative of tan x is sec squared x. And derivative of cosec x, well, derivative of sec x first of all, that would be sec x tan x. Derivative of cosec x is minus cosec x cot x. Okay, so that's minus cosec x cot x. And the derivative of cot x finally is minus cosec squared x. So those are all the trigonometric derivatives, and then on top of that you have the exponentials. So y equals e to the x gives you dy dx equals to e to the x itself. So this is one function where the derivative is itself. And finally y equals ln x gives you dy dx equals to 1 over x. Okay, so that's the natural log function, so the derivative of that is 1 over x. So those are the derivatives of 8 functions that you're going to learn in this course. Okay, now I'm going to go through chain rule. Okay, so I'm sure this will be in your textbook or whatever the book you're using. Let's now do chain rule. Okay, so chain rule is an interesting rule because it allows us to differentiate complicated functions without any major problems. So let's say we have something like this. If you have y equals, let's say 2x minus 3 to the power 8, and they will say find dy dx. Okay, so this is power 8 here. Okay, I don't know if you can see it, so let me just write it slightly below. It's 2x minus 3 to the power 8. So obviously one way of doing it is multiply this bracket 8 times and then differentiate the terms. Obviously that's going to take a long time, so the best thing to do is use the chain rule. Okay, so we're going to use something called the chain rule. So it's like, this function is like a set of chains, so we can actually use the chain rule to break it down. So what I'm going to do, I'm going to let u equals to 2x minus 3. So that's the inside function if you look at it. Okay, so I'm going to let u equals to that. So du dx equals 2. Now if u equals to 2x minus 3, so y equals to u to the 8, because instead of 2x minus 3 I can write u in there. So now dy du, so I'm differentiating y respect to u, so that will be 8u to the 7. Okay, so now that's same as 8. Instead of u I can put the value of u in terms of x here, which is 2x minus 3. Remember, u is equal to 2x minus 3, so instead of u here I can write 2x minus 3 to the 7. So now dy dx is equal to dy du times du dx. So if you look at it, the du's here and there, they actually cancel. So you end up with dy dx, which is what you want. So this is same as, so dy du times du dx, so which is going to be 2 times 8 bracket 2x minus 3 to the 7, which is same as 16 2x minus 3 to the 7, and that is a derivative of 2x minus 3 to the power 8. Now it's very simple. You can do this directly as well. All you have to do, you have to mentally differentiate this, so that gives you 2, and then you have to times by this 8, so that gives you 16 at the front, which is what we got here, and then you have to reduce the power by 1 here. But this is the actual proof of it. So if you are struggling to do chain rule direct, what you do, you use this U substitution and it will give you the correct answer every time. And it's not only algebraic terms we can use this for. So for example, if we have y equals to sine 3x, okay, so you can use the same thing here. So let u equals to the inside function, which is 3x. The chain rule is basically a function inside a function, okay. So du dx equals to 3. So y equals to sine u now, because 3x is equal to u. So dy du equals to cos u, because when you differentiate sine you get cos. So now that's same as cos 3x. So dy dx equals to dy du times du dx, which is basically that times that, so it gives you 3 cos 3x. There you go. So that's what you get when you differentiate sine 3x. In particular, if you differentiate sine nx, n any number, it gives you n cos nx. Okay, so that is the chain rule. So let's try and do one more complicated question. Okay, I'm only going to use chain rule here today. I will teach you the product rule and the quotient rule in a different video. Obviously, product rule is fairly simple. Quotient rule can be slightly more complicated, but you need to be able to break down the chain rule very well before you actually get on to those other topics. Okay, so let's do a question. So let's say y equals to e to the power of x squared plus 5. Let's say x squared plus 5x plus 2. Okay, so let's make it complicated. Okay, let me just write it slightly below. So y equals to e to the power of x squared plus 5x plus 2. Okay, so you do the same thing. You let u equals to x squared plus 5x plus 2. So you let u equals to the inside function. So du dx equals to 2x plus 5. So that makes y equals to e to the u. So dy du equals to e to the u itself, which is basically e to the x squared plus 5x plus 2. So now dy dx equals to dy du times du dx. So dy du is that, du dx is that. So let's write that bit first. So it'll be 2x plus 5 bracket e to the x squared plus 5x plus 2. In general, what's actually happening is you need to multiply the derivative of the main function by the derivative of the inside function. So the derivative of the inside function is the inside function is x squared plus 5x plus 2. Here, if you differentiate that, you get 2x plus 5. So you have to times that by the derivative of the main function, which is e to the power, which will give you the e to the power, and that's the final answer. But if you cannot get it direct, always use the U substitution, it will give you the correct answer. It will take you 10-15 seconds extra, but it might be worthwhile doing it if you're getting stuck with it. Okay, so let's do one more question. So let's say we have y equals tan e to the x. Okay, so this is an interesting question. Let me make it a little bit more complicated. Let's say e to the x squared. So tan equals e to the x squared. Okay. So we have a function inside a function inside a function. So what I'm going to do, I'm going to let u equals to e to the x squared. So du dx, so I'm going to do the chain rule directly here. So if I do the chain rule directly here, I have to differentiate x squared first, which is 2x, and e to the x squared is e to the x squared. When you differentiate it, e to the power stays as it is. So let's go through that again. So e to the x squared, the derivative of that will be, so you differentiate x squared first, that gives you 2x at the front, and then you write e to the x squared, because e to the x squared derivative itself is e to the x squared. Okay, so now if u equals to e to the x squared, so y is equal to tan u. So dy du equals to sec squared u. So that's same as sec squared e to the x squared. Okay, just because there are complicated functions, don't worry, we're just going to keep it simple. Okay, if we follow the process, we will get the right answer every time. So now dy dx equals dy du times du dx. Okay, it's the same formula every time. Dy dx equals to dy du. This is dy du times du dx. Okay, so dy du is this one, du dx is that one. So if you multiply it together, let's write this in order. So it'll be 2x e to the x squared sec squared e to the x squared. That's the answer. So that is how you differentiate using chain rule. So you can try few of these questions which I'll write down here. So you can try y equals x squared plus 5x minus 1 to the 3. Try differentiate that using chain rule. And then secondly, let's do y equals to sine of x squared minus 5x plus 3. And let's do one more. Let's do y equals e to the sine x. Okay, so let's differentiate that as well. So you got few functions to practice. Let u equals to the inside function and always try it, you'll get the answer every time. Okay, so I'm going to leave it there. It's been a slightly longer video than I expected, but in the next video I'll try and do the product rule. Okay, thank you.